Hello my lovely students, you're welcome to a new lesson. Today, I shall be teaching you linear inequalities. Inequality is a mathematical statement that two algebraic expressions are not equal. Let's learn more about linear inequalities. The common inequality symbols or signs, their meanings and number line graphs are as follows. Here we have the four inequality symbols. The first inequality symbol, which means is greater than, has a number line graph with an empty ring and an arrow pointing to the right. The second inequality symbol means is less than, and it has a number line graph with an empty ring with an arrow pointing to the left. The third inequality symbol means is greater than or equal to, and the number line graph is a shaded or a colored ring with an arrow pointing to the right. While the fourth inequality symbol means is less than or equal to, and the number line graph is a shaded or a colored ring with an arrow pointing to the left. Please take note of these four inequality symbols, their meanings and their number line graphs. Please note the following points about inequalities. Point number 1. An inequality remains true when a quantity is added to or subtracted from both sides. Point number 2. An inequality remains true when both sides are multiplied or divided by a positive quantity. Point number 3. An inequality remains true when both sides are multiplied or divided by a negative quantity, provided the inequality symbol or sign is reversed. Once again, please take note of these 3 points about inequalities. Moving on, let's see some solved examples about linear inequalities in one variable. Example 1. Solve the following inequalities and show the solutions on the number line graph. Question A. 5x minus 4 is less than 11. Question B. 3 into x plus 4 is less than or equal to 5x. Question C. Minus 2 into 13 plus x is greater than or equal to 9 plus 5x. Question D. 3 into x minus 6 is less than 9 into x minus 1. And question E. 5x minus 1 divided by 3 minus 1 minus 2x divided by 5 is less than or equal to 8 plus x. Let's see the solution to example 1a. Now please note that we solve inequalities the same way we solve equations. Now for question 1a, solving 5x minus 4 is less than 11, we are going to collect like terms. That gives us 5x is less than 11 plus 4, which is 5x is less than 15. Then to solve for x, we divide both sides by 5. That will give us x is less than 3 as the solution to the inequality in question 1a. Next, let's show the number line graph of the solution x is less than 3. Can you draw the number line graph for x is less than 3? Will the number line graph here involve an empty ring or a colored or shaded ring? Also, will the number line graph involve an arrow pointing to the right or an arrow pointing to the left? Let's see if you are right. Of course, the number line graph for x is less than 3 involves an empty ring on the point 3 and an arrow pointing to the left in the line x. I hope you got the number line graph right. Moving on, let's see the solution to question 1b. Now to solve the inequality 3 into x plus 4 is less than or equal to 5x, here we remove the brackets. That gives us 3x plus 12 is less than or equal to 5x. Collecting like terms for x, we have 3x minus 5x is less than or equal to minus 12. That should give minus 2x is less than or equal to minus 12. Then, to solve for x, we divide both sides by minus 2 and reverse the inequality. Don't forget, whenever you divide or multiply both sides of an inequality by negative quantity, you reverse the inequality. So that gives us minus 2x divided by minus 2 becoming greater than or equal to minus 12 divided by minus 2. In other words, the original less than or equal to in the question has been reversed to greater than or equal to. Please take note of this step. The solution to the inequality becomes x is greater than or equal to 6. Next, we are to show the number line graph for the solution. Once again, can you draw the number line graph for x is greater than or equal to 6? Will the number line graph involve an empty ring or a colored or shaded ring? Also, will the number line graph have an arrow pointing to the right or an arrow pointing to the left? Let's see if you are right again. The number line graph for x is greater than or equal to 6 involves a shaded ring on the point 6 and an arrow pointing to the right on the line x. I hope your number line graph is correct. Let's see the solution to question 1c. To solve the inequality minus 2 into 13 plus x is greater than or equal to 9 plus 5x, we remove the brackets and collect our like terms. In doing this, we will get minus 7x is greater than or equal to 35. Next, to solve for x, divide both sides by minus 7 and reverse the inequality. That will give us minus 7x divided by minus 7 should be less than or equal to 35 divided by minus 7. Once again, the original greater than or equal to in the question has been reversed to less than or equal to, because we are dividing both sides here by a negative quantity, which is minus 7. This will give us the answer x is less than or equal to minus 5. The number line graph for the solution is as follows. The number line graph for x is less than or equal to minus 5 involves a shaded ring on the point minus 5 and an arrow pointing to the left on the x line. Let's see the solution to question 1d. Solving the inequality 3 into x minus 6 is less than 9 into x minus 1. Once again, we solve the inequality by removing the brackets and collecting like terms. That will give us minus 6x is less than 9. To solve for x, divide both sides by minus 6 and reverse the inequality. The inequality becomes minus 6x divided by minus 6 is greater than 9 divided by minus 6. The solution for the inequality is x is greater than minus 1.5. The number line graph for the solution is as follows. The number line graph for the inequality x is greater than minus 1.5 involves an empty ring on the point minus 1.5 and an arrow pointing to the right on the line x. Let's see the solution to question 1e, which is 5x minus 1 divided by 3 minus 1 minus 2x divided by 5 is less than or equal to 8 plus x. Now this inequality is a fractional inequality. To remove or clear the fractions, we're going to multiply through by the lowest common multiple of the denominators. The LCM of 3 and 5 is 15. So multiplying the inequality by 15, we're going to have 15 multiplying 5x minus 1 divided by 3 minus 15 multiplying 1 minus 2x divided by 5 is less than or equal to 15 multiplying 8 plus x. When we multiply through this way with the LCM of denominators, we are going to remove the denominators. That means clearing the fractions, because denominators is creating the fraction. So the fractional inequality becomes 5 into 5x minus 1 minus 3 into 1 minus 2x is less than or equal to 15 into 8 plus x, which is now a simple inequality, no longer a fractional inequality. From this point, removing the brackets and collecting like terms, we are going to have 16x is less than or equal to 128. Dividing both sides by 16 to solve for x, we are going to have 16x divided by 16 is less than or equal to 128 divided by 16. When we solve this, what will be the solution to the inequality? Let's see if you are right. Dividing both sides by 16, we are going to have x is less than or equal to 8 as the solution to the inequality. I hope you got this right. The number line graph for the solution is as follows. The number line graph to the solution of the inequality, which is x is less than or equal to 8, involves a colored or shaded ring on the point 8 and an arrow pointing to the left on the x line. Please take note of all the solutions to the linear inequalities in one variable in example 1. Moving on, let's see our second example. Example 2. Question A. Solve the inequality 11 minus 2x is less than 4. Question B. Given that x is an integer, find the 3 lowest possible values of x. Let's see the solution to question 2A. The inequality is 11 minus 2x is less than 4. Solving the inequality by collecting like terms, we are going to get minus 2x is less than 4 minus 11. That will give us minus 2x is less than minus 7. To solve for x, divide both sides by minus 2 and reverse the inequality. That will give us minus 2x divided by minus 2 is greater than minus 7 divided by minus 2. The solution to the inequality is x is greater than 3.5. Now, if x is greater than 3.5 and x is an integer or a whole number, what will be the 3 lowest possible values of x in question 2b? Let's see if you got that right. The number line graph for the solution of the inequality, which is x is greater than 3.5, should involve an empty ring on the point 3.5 and an arrow pointing to the right on the line x. From the number line graph, x is an integer, that is any whole number. If x is greater than 3.5, then x should be 4 or 5 or 6 or 7 or 8 or 9 or 10 and so on to the right of the number line. The 3 lowest values of x are 4, 5 and 6. I hope you got that right. Moving on, let's see our third example for linear inequalities in one variable. Example 3. Given that x is an integer, find the 3 greatest values of x which satisfy the inequality 7x plus 13 is less than 2x. Let's see the solution to example 3. Solving the inequality 7x plus 13 is less than 2x. We are going to collect like terms to simplify. That should give us 5x is less than minus 13. Next, let's divide both sides by 5. That will give us 5x divided by 5 is less than minus 13 divided by 5. The solution to the inequality is x is less than minus 2 whole number 3 over 5. Next, let's draw the number line for the solution and determine the three greatest values of x. The number line graph for the solution x is less than minus 2 whole number 3 over 5 should involve an empty ring on the point minus 2 whole number 3 over 5 and an arrow pointing to the left on the number line x. Since x is an integer, that is any whole number, if x is less than minus 2 whole number 3 over 5, then x should be minus 3 or minus 4 or minus 5 or minus 6 or minus 7 or minus 8 or minus 9 or minus 10 and so on to the left of the number line. The three greatest values of x are minus 3, minus 4 and minus 5. I hope the solution to example 3 is clear to you. Moving on, let's learn about combined inequalities in one variable. Inequalities in one variable can be combined in these four forms. Number 1, a is less than x less than b. Number 2, a is less than or equal to x less than b. Number 3, a is less than x less than or equal to b. And number 4, a is less than or equal to x less than or equal to b. Here a is the smallest number and b is the largest number in the range of values for x. The number line graphs for these four combined inequalities are as follows. The number line graph for the combined inequality a is less than x less than b involves two empty rings on the points a and b and the line joining the empty rings on line x. For the combined inequality a is less than or equal to x less than b, the number line graph involves a shaded ring on the point a and an empty ring on the point b and the line joining both rings on line x. For the combined inequality a is less than x less than or equal to b, the number line graph involves an empty ring on the point a and a shaded or colored ring on the point b and the line joining both rings on line x. Lastly, for the combined inequality a is less than or equal to x less than or equal to b, the number line graph involves two colored or shaded rings on both points a and b and the line joining both rings on line x. Please take note of these four number line graphs for the four combined inequalities in one variable. Moving on, let's solve some examples on combined inequalities in one variable. Example 4. Question A. What is the range of values of x for which 2x plus 5 is greater than or equal to 1 and x minus 4 is less than 1 are both satisfied? Question B. Draw a number line to show the range of values of x. Let's see the solution to question 4a. Now to find the range of values for x, let's solve the first inequality, which is 2x plus 5 is greater than or equal to 1. Collecting like terms, we have 2x is greater than or equal to 1 minus 5, which should give us 2x is greater than or equal to minus 4. Dividing both sides by 2, we have 2x divided by 2 is greater than or equal to minus 4 divided by 2. The solution to the first inequality is x is greater than or equal to minus 2. Next, let's solve the second inequality, which is x minus 4 is less than 1. Collecting like terms, we have x is less than 1 plus 4. The solution to the second inequality is x is less than 5. Next, we are going to combine these two inequality solutions. Combining the results, we have the first inequality, which is x is greater than or equal to minus 2, and the second inequality, which is x is less than 5. Here we must ensure that we will write the smallest value first and the biggest value last. The smallest value is x is greater than or equal to minus 2. Reversing the smallest value, we are going to have minus 2 is less than or equal to x. Combining this arrangement with the biggest value, which is x is less than 5, we are going to have a combined inequality, which is minus 2 is less than or equal to x is less than 5. Hence, both inequalities are satisfied if minus 2 is less than or equal to x is less than 5. Next, let's draw the number line to show the range of values of x in question 4b. The combined inequality remains minus 2 is less than or equal to x is less than 5. The number line graph to show the range of values of x is displayed here. In the number line graph, since we have less than or equal to close to minus 2, we are going to have a shaded or a colored ring on the point minus 2. While because we have just less than close to the point 5, we are going to have an empty ring on the point 5 on the number line for x. Please ensure a line should join both rings to show that the inequalities are combined. Let's see our final example for combined inequalities in one variable. Example 5. State the range of values of x represented by each number line. In question A, we have a shaded or colored ring on point 0 and an empty ring on point 6. Also, we have a combination in question A for line x. In question B, we have both shaded or colored rings on the points minus 1 and 5. And also we have a combination for the line x. In question C, we have an empty ring on point minus 3 and a shaded or colored ring on point 3. Also we have a combination for line x. In question D, we have both empty rings on points 7 and 11 and a combination for the line x. While in question E, we have a shaded or colored ring on points minus 5 and an arrow pointing to the left, and an empty ring on point minus 2 and an arrow pointing to the right on the line x. In question E, we do not have a combined inequalities. Rather, we have two separate inequalities. Now, let us take the range of values of x represented by each of these number lines. Here are the solutions to example 5. In stating the range of values of x represented by each number line, let's see the solution to question 5. The inequality in question A is 0 is less than or equal to x is less than 6. The inequality in question B is minus 1 is less than or equal to x is less than or equal to 5. The inequality in question C is minus 3 is less than x is less than or equal to 3. The inequality in question D is 7 is less than x is less than 11. While for question E, we have two separate inequalities. The two separate inequalities in question E are x is less than or equal to minus 5 or x is greater than minus 2. Please note that the number line from question A to D involves combined inequalities, while the number line in question E involves two separate inequalities, which are x is less than or equal to minus 5 or x is greater than minus 2. I hope the solutions to example 5 they are all clear to you. Lastly, let's learn about two other types of inequalities. Number 1, quadratic inequalities, and number 2, absolute value of inequalities. Number 1, quadratic inequalities. Point number 1. Quadratic inequalities such as x squared minus x minus 6 is less than or equal to 0 can be solved by first finding the critical values by replacing the inequality sign with the equal sign to obtain a quadratic equation. Point number 2. Solve the quadratic equation to obtain two critical values or roots. Point number 3. The critical values split the number line into 3 regions. Point number 4. Choose a value of x in each region to test the given quadratic inequality. Number 2. Absolute value of inequalities. Point number 1. The absolute value of a number gives the magnitude of the number regardless of the sign, that is either positive or negative. Point number 2. The absolute value of x is denoted by two straight lines beside x, which represents plus x or minus x. That means the absolute value of x is plus or minus x. Point number 3. The absolute value of x is sometimes called the modulus of x. Point number 4. An example of the absolute value of inequalities includes the absolute value or the modulus of 2x minus 3 is less than 4. Please take note of this extra information on other types of inequalities in addition to linear inequalities. Thank you very much for going through the lesson today. I want to advise that for you to get more information about the topic linear inequalities, please continue to read your textbook. Don't forget to attempt your quiz and your assignment. I hope to see you again in our next class. Until then, it is goodbye for now. Thank you very much.